Alright, Algebra 2, Chapter 8, Review Part 1. The first part of your test is going to ask you to graph exponential and log functions. So let's go ahead and work on that. Let's go ahead and pull up a graph. And let's go ahead and work on an easy one first, an exponential function. So let's say you have y is equal to 2 raised to the x. Alright, so we need to figure out what our domain and ranges are going to be. With exponential functions, what you're going to do is to determine your range, look for your k value. And if we look at our function here, we see we have no k value. So we would say our range is going to be greater than 0, and our domain, which is our x values, can be any number that we can think of, so we would say all real numbers. Alright, so what we're going to do is make an xy table. Choose values that are easy to plot, so I know when I have 0, 2 to the 0 power is 1, 2 to the first is 2, and 2 squared would be 4. Alright, so 2 or 3 points should suffice. Go ahead and plot 0, 1, 1, 2, and 2, 4. Draw your curve in the upward direction. Okay, so you'll have one very similar to that. If you look at the function again, we have no h, no k, so no vertical or horizontal shift. Alright, now let's go ahead and graph a log function. Alright, so we have y is equal to 3 times log x. We need to figure out our domain and our range. Now that we're dealing with log functions, in order to figure out what your domain is, you're going to look at your h value. And we see we have no h value here, so we're just going to say x has to be greater than 0, and my range is going to be all real numbers. We're going to do an xy table. Since my domain says I have to start with numbers greater than 0, I am going to go ahead and start with 1. So first thing you should figure out is what is log 1. Right, and if I punch into my calculator, okay, we know that 10 to the 0 power is equal to 1, so when x is 1, then y is going to be 0, because log 1 is equal to 0, 0 times 3 is 0. Alright, the next value I'm going to go ahead and use is 10. 10 is greater than 0. Alright, I know that log 10 equals 1, and 1 times 3 would be 3. So when x is 10, y is 3. Alright, I'm going to go ahead and graph those 2 points now. I'm going to graph 1, 0, and 10, 3. Okay, and we're going to draw a nice curve in the upward direction. Alright, let's go ahead and do another exponential function. Let's say we have y is equal to 2 times 2 raised to the x minus 1, okay, plus 1. Now if you notice, we have some h values and we have a k value, so that means I have a horizontal shift and I have a vertical shift. So first let's figure out our domain and our range. What we want to do is figure out our range, because that's the easiest exponential functions. When we're looking at ranges, we're looking at our k values. Since k is equal to 1, my range is going to be y is greater than 1. Domain is just simply all real numbers. We're not restricted. Alright, so xy table. Let's choose values that are going to make it easy to graph. So when x is 1, what we're essentially saying is 2 to the 0 power plus 1. 2 to the 0 power is 1. 1 plus 1 is 2. Alright, when x is 2, we're saying 2 raised to the first power, because 2 minus 1 is 1. 2 to the first is 2. 2 plus 1 is 3. So when x is 2, y is 3. And let's do one more. When x is 3, we're basically saying 2 to the 3 minus 1, which is 2 squared. 2 squared is 4. 4 plus 1 is 5. So go ahead and graph your points. 1, 2, 2, 3, and 3, 5. And if let's say we have y is equal to 2 to the x minus 4. Alright, and if you look at the function, you can see we have no h because there's no value attached to the x, but we do have a k. Now with exponential functions, we know that our k's determine our range. So this is negative 4 for k, so we're going to say our range has got to be greater than negative 4, y greater than negative 4. Domain is going to be all real numbers. Okay, xy table, again choose values that are going to make it easy to graph. 2 to the 0 power is 1, 1 minus 4 is a negative 3. Alright, so let's go ahead and do 2. When x is 1, we get 2 to the first, so that's 2 to the first is 2. 2 minus 4 is negative 2. 2 squared, when x is 2, 2 squared is 4. 4 minus 4 is 0. Alright, let's go ahead and graph. Alright, so we have 0 down to negative 3. 1 to negative 2, and then 2, 0. You can see your curve, and draw your exponential growth. Alright, let's go ahead and simplify some number e's, simplify some expressions. Alright, so let's say we have a negative e cubed times e to the negative square. Alright, take a look at your bases. Our bases are the same, they are both e. So we would get e, and then we have to subtract, we need to add those exponents. So 3 plus a negative 2 is going to give me 1. Alright, but since one of my e's is negative, I need to bring that negative out. So we get negative e to the first, or just simply negative e. And let's try another one. Let's do 3e times 5e times a negative e to a negative 4. Alright, so first thing we're going to do is go ahead and take care of this 3 times 5, and that's going to give us 15. Now we can look at all the other terms here. You can see that my bases here are all e's. Alright, and our exponents, the 2 of them, are 1. Alright, so when our bases are the same, that means we have to add all of these exponents. So we get 1 plus 1 is 2. 2 plus a negative 4 is a negative 2. Alright, so what we really get is, because one of my e's is negative, we get a negative 15 e to the negative 2. Since we don't want a negative exponent, we're going to throw that e in the denominator. So we get negative 15 over e squared. Alright, let's go ahead and simplify some log expressions. Let's say we have log 1 of 1 over 1,000. Okay, so basically you're saying is 10 to what power is going to give me 1 over 1,000? Well, think of it this way. We have a fraction here, so chances are my exponent is going to be negative. What number can we multiply? Or how many times can we multiply 10 to itself to get 1,000? Well, we know that we can do 3, right? But since we want a fraction, we'll just say 10 to the negative third is going to give us 1 over 1,000. Right, so your answer would be negative 3. Alright, let's go ahead and do another one. Do log base 5 of 15,625. And you need to think of it this way. 5 raised to what power is going to give me 15,625? Alright, so 1/2 raised to what power is equal to 32? Alright, we're dealing with a fraction again, so chances are that we need a negative exponent. So try to think, what number or how many times can you multiply 2 to itself to get 32? Well, I know that 2 to the 5th gives me 32, but what does 1/2 to the negative 5th give me? Well, split the reciprocal, keep the exponent but get rid of the sign. 2 to the 5th gives me 32, so 1/2 to the negative 5th also gives me 32. So x is going to equal negative 5. Alright, let's do one with a natural log. Let's say we have natural log e to the 7th. Alright, well, in class we learned that natural log is the same as saying log with base e. Alright, so we could say log base e of e to the 7th. Alright, when our bases are the same, we can cancel them out. Alright, and we're only left with the exponent. So natural log e raised to the 7th is going to be equal to 7. Alright, this concludes part 1 of your chapter review. Please look for part 2.